Hi everyone, this is Brian from the Good Wood Studio. I wanted to take the next video here and talk about dust collection. This little project was a tremendous undertaking for me. I had a lot of help from a lot of friends, did a lot of research, did a lot of reading, and figured out kind of what the best design was for me. We'll talk about fittings, we'll talk about the overall construction, we'll talk about the design and the flow of how dust collection should be. So stick around. Okay, so let's talk about some of the pieces or fittings you're going to need to get started in your dust collection project. The first thing you're going to need is you're going to need to determine what piping you're going to use. I personally used PVC. It's a lot cheaper than to go with certain metal ducting. There's a lot of metal ducting solutions out there, such as Nordfab or just standard. People use HVAC type fittings. I found PVC to be a lot more economical for me. Plus, I can change the fittings as I need, or if I need to move a tool somewhere, it's a lot easier for me to adjust. So in going with PVC, I chose the SDR35 green piping. You'll also hear it in home improvement stores as DWV or waste pipe, sewer pipe. Um, this was probably the best bang for the buck for what I could use. Next thing you can use is a bunch of couplers. Couplers will join two pieces together, obviously. I've got a 45-degree elbow. The reason I went with 45s was I wanted to make a smoother transition. You want to kind of stay away from using 90-degree elbows, which has a very sharp or right angle transition, and that defeats a lot of the suction power you'll find through your design. There are out there smooth transition 90s that are longer, that have more of a radial curve. Those tend to be a little bit harder to find in home improvement stores. You might go to like sprinkler supply or plumbing supply stores that would have those, but they are very costly. Next thing you can use is a cap. If you're ending a piece or going off of a Y and you don't have a fitting or don't have something to go to that spot just yet, you can cap it off. Lastly, obviously, a Y connector is really useful. I try to stay away from T's for the same reason as right angles or 90-degree angles. A Y allows for a smoother transition. Your airflow is going to go softer, and more suction is going to happen this way than through a T, which is going to hit an abrupt and go. Okay, so let's talk about some of the design aspects of your dust collection system. One of the first things you're going to want to do is you want to get a shop drawing together of your shop, the layout, where your tools are or where you want them to be. And then from there, you can actually start planning out how your ductwork is going to lay out. In the case of mine here, I have a drawing that I made that is kind of a trunk and branch type of configuration. So the trunk being from the dust collector going all the way through end to end of the shop. And by doing that, I have the maximum suction power that I can get. And it's also referred to as a centralized dust collection system, where the central is the dust collector itself, and then it branches off into aspects. So I've got my branches here that go to each of the individual tools, to a jointer, router table, miter saw, my table saw, and right here, not set up yet, but I've got a branch here for a floor sweep that I'm going to use. And then when you look at how you're going to terminate and select your dust termination, you want to use the blast gates where you can at the Ys. You'll notice here as I have my Y fitting, I've got a blast gate right here. I've got a blast gate at this Y. I've got a blast gate here at these connectors here. And the logic behind that is really simple. When I'm plotting out how I want to terminate my dust collection and get the best possible suction to each tool, I want to terminate as close to the main lines or as close to these branches as possible. If I'm terminating down at the tool or using a blast gate at the tool, that air has to travel all the way down the branch, all the way down to the tool itself. And that's a loss of pressure and a loss of suction right there. That is just going to defeat the purpose of what you're trying to accomplish. So if you terminate up here, basically you are shutting off all the air going back. You're not going to have a whole bunch of wasted air coming up and around. So best to definitely terminate where you can, as close to the main line as you can. And in regards to that, you also want to make sure that you have your maximum piping down to the tool. So I have 6-inch fittings here, 6-inch piping all the way down to the tool, where I transition to 4-inch and use a flex hose. Flex hose wise, you don't want to use more than 2 feet if possible. And again, this just has to do with static pressure, with CFM, overall suction. If you're using anything more, you're actually just defeating the purpose of suction. So it's best to just transition to 4, as close to the tool as you can. In this case, I've got about 2 feet of flex here. I've got my reducer, and I've got 6 inches up here. This is an exception that I had to make. I had to use a blast gate right here close to the tool, only because up here, as you can see, my blast gate hits the fittings up here. I couldn't even put another blast gate right there. So just to explain that through. And then going here over to the jointer, for example, same thing. I've got 6 inches all the way down to the jointer, and then I've got about 1.5 feet where it goes right into the jointer at 4 inches. On a jointer, there's a lot of chips there, so it's even better to use 6-inch all the way through if your jointer will support it. Some of them just have very small fittings for 4-inch. In the case of my planer here, I went ahead and used 4-inch off of the 6-inch. I did a 6-to-4, and the reason for that was with a DeWalt planer, I've got a blower that's built in that blows the chips out. When you combine that with the suction of where the dust collection is, that made for a easy transition for me, or easy thought process to say, well, if I've got it blowing and I've got it sucking at the same time, then the 4-inch should be probably all I need for this size of planer. Now, if I upgrade to a larger planer or something a little more heavy duty commercial, I'm going to go 6 inches straight to the tool. Let's talk about dust collection for a miter saw real quick. In the case of mine is still in progress, but I wanted to talk about it here because there's a lot of ground to cover on how to get dust out of a miter saw. One of the aspects of containment that I used was I built this little miter saw box that fits around the miter saw. It helps contain a lot of the dust. A lot of it is contained within the box. Sometimes, depending on the type of wood you cut, it still tends to get out. So that was one of the reasons I wanted to actually use the dust collector rather than having a vacuum under here, which I do right now. I've got a fine vacuum under my miter saw, but the dust collection on a lot of your miter saws is very lackluster. Sometimes you have these smaller shrouds, and they don't pick up a lot of dust. If you read reviews for a lot of tools, even your high-end miter saws, the dust collection is always something that's a little bit left to be desired. So how do we overcome that? In the case of what I want to design here, I want to have a pipe coming all the way down here, coming into my miter box, and the way that this miter saw is tilting down, or you're making your cuts, you can see where the dust is going to come out. The dust is just going to be spitting out of this area here. And so if I've got a 6-inch duct that's going to come right down into this, and that suction is going to be at about 600 CFM, based on my other measurements in my other areas, that's going to pick up a lot of this ambient dust that's coming around here, especially when I'm cutting through larger pieces of wood or plywood or things of that nature. And so I wanted to make sure that that I had it coming down as close to this as possible. So it's going to actually stick through the box. It's not going to just stop at the box, but it's actually going to come through right back to just behind the motor housing here, and will stop. And that way it's going to go right in, and that should alleviate a lot of the problems with this. Now you'll see some configurations also where they have a pipe coming in at each side, your left and your right. You can do that with some transition, like a Y that transitions into two 4-inch. I think you're going to get a lot less suction out of that, but I also think it would be effective in getting that ambient dust side to side. In my case, and what I'm thinking is I believe that a 6-inch is going to be the best way. So from the dust collector here, you'll notice that I did a straight out pipe, and then softly transitioned into a 45, and then softly transitioned into another 45 to go out through the trunk. And the process on that is fairly straightforward. I want to get the most maximum air power going through to start from the machine itself. If I have flex hose or bending off right to a 90 degree, or some people have a bunch of Y fittings right here, that is defeating a lot of the suction power right at the source. And the last thing you want to do is defeat it at the source. You can get a lot of turbulence or a lot of shaking or vibration if you do a lot of your fittings right at the source. And so just in what I've read and what I've looked at from a design perspective, I found that running about 5 feet more, if you can, of straight PVC or straight ducting, and then going into a soft transition to get where you need to go, is going to be the best result for you. I think, running it this way for me worked very well, and I had very little loss of pressure at the tools themselves. I also reduced right here at the dust collector. This dust collector does 8-inch, and then it's got a fitting that has 4 inches. Or you can just go straight 8, and I went ahead and used a Fernco reducer to go from 8-inch to 6-inch, and that's how I was able to keep 6 inches all the way through the system up to each tool. So let's talk about a few of the don'ts in dust collection. If we go back to my shop diagram here, let's take a look here at this was in my early drawings here. You'll notice here how I have a Y and then another Y right after it. You want to keep your Ys flowing in the same direction each time. If you look at a tree and branch configuration, you'll notice that you have, a branch, a branch, a branch. These allow for the better part of dust collection. They are all going in the same direction back to the dust collector. Now, if you look at these over here, you'll notice that I went back this way and back this way. This is an absolute don't. Will it work? Yes, it will work, but you're going to take your suction and you're going to reduce it significantly, just because you are trying to flow back, and you're actually going in a forward motion here and then back. That dust is you're going to find clogs or potential traps here in doing that. So coming out here from my dust collector, the best thing I can do is transition this way and make a branch this way, and same thing over here to my sander. I could make a transition this way instead of the opposite way to have better dust flow. Another thing, which I talked about a little bit earlier, is making sure that your blast gates are as close to the central part of your branch or trunks as possible. Blast gates at the tool itself reduces a lot of the pressure. In the case of my table saw here, I've got a blast gate right here just for the purpose of my table saw itself and my future overarm dust collection here. I like to be able to control those as I need. Blast gate wise up here though, again, trunk and branch. So in regards to the fittings themselves, I've had some questions. And did you use PVC cement or anything to fit it all together? And the answer is you really don't need it. In fact, you can just fit everything together. One of the benefits of that is you could actually resize, or if you need to change something or you move a tool, that you can take it apart and put it back together. I can use silicone tape at the joints here, which I've purchased to make it as tight or as loss free as possible. Where I did use cement is where I drop down here to a tool, and the logic behind that is this piece right here plus your blast gate is kind of heavy. So right here I did go ahead and use PVC cement, and that way it doesn't just fall off. But everything else up here, over here, is completely loose and is fully adjustable, fully able to be disassembled, and that way I can change things out on the fly if needed. Well, that's a high-level view of my dust collection system. I hope you found it helpful. If you have any comments, please use the comment section below. Hopefully you like and subscribe to my channel here. There will be plenty of other videos coming up soon. The next video that I'll be working on is the review of the Laguna 3 horsepower dust collector, the C-Flux. So hope you stay tuned, and thanks for watching.